Hi there, Miss Heaton again. We are going to be talking today about thermochemistry, and you can see these sections in your textbook if you'd like to see further practice on any of the topics. When I give this lecture or discussion in class, we usually start with this question. So even though you're not in class, I want you to take a minute to pause and think about the question. How are heat and temperature related? Many people think that heat and temperature are the same thing. In everyday life, we might use those words interchangeably. But in chemistry, they mean different things. Temperature is going to actually tell you how quickly, how much speed the particles in any substance have. So if you consider a pie sitting on a windowsill, if it just came out of the oven, it is hot, right? So the particles in it are moving very quickly. Whereas maybe the air outside on a cool fall day is a lot cooler. Therefore, because it has a lower temperature, its particles are moving more slowly. And we would measure each of those temperatures with units of perhaps degrees Celsius, or the SI unit would be Kelvin. In this unit, from time to time, we will use Kelvin. You just need to be aware that it's also a unit of temperature. Later on, we'll use this conversion, although it won't be very important today because we're just talking about changes in temperature. But Kelvin is always going to be 273 degrees above the temperature in Celsius. Heat, on the other hand, is a little bit different. Heat is the transfer or flow of energy between two different objects due to being at different temperatures. So heat isn't something possessed by one substance. It is energy that flows between the two of them. So let's consider our pie example again. It's sitting on the windowsill on a cold day. What's eventually going to happen to the pie? Well, it's going to cool off. Its heat will flow from the hot pie to the colder air around it, making the air warm up. And at the molecular level, what's happening is that those hot particles are colliding with the colder temperature-wise particles, the slower particles, making them speed up and thus get to a higher temperature. And heat will flow from the hot substance to the cold substance, the thing at the lower temperature, until they're at the same temperature. It does not matter though. Something doesn't possess a certain amount of heat. Remember, heat is just energy. Later on in this unit, it's going to become important to know that heat isn't created or destroyed, just like in the lab that you did the other day. You saw that mass wasn't created or destroyed. It was conserved. Heat is the same way. Energy is the same way. And the units you use on heat is not degrees Celsius or Kelvin. You might see units of joules or calories. So in this unit, we're going to be studying thermochemistry, which is basically the study of heat being transferred from one substance to another. And to kind of qualitatively talk about that, we might use the words endo or exothermic. From biology, you may remember the words endoskeleton and exoskeleton. The difference is the same here. In an exothermic reaction, you are going to be losing heat. So if something is exothermic, it is losing heat. So let's consider that pie. Is it exothermic? Well, yeah, because we said heat was flowing from the pie to the air around it. So the pie is exothermic. Now, if you, as the surroundings, were going to stick your finger into the pie, how would it feel to your hand? Well, it would feel hot, right? Because your hand is gaining the heat that the pie is giving off. On the other hand, something that's endothermic, like an ice cube, is going to be gaining heat. You can think of it this way. Exothermic sounds like exiting, so it is losing heat. Endothermic means internal. So heat is going into that system. So the ice cube, if you were to touch it, since heat is going into the ice cube, where is it getting heat from? Well, it's taking energy from the particles in your hands. So your hand is getting colder. So it's going to feel cold. Now, I want you to know that there is no such thing as cold. There's no such substance as heat, but we talk about heat being transferred from one thing to another. You can't transfer cold from the ice cube to your hands. It doesn't work that way. We always talk about heat going from the warmer thing to the cooler thing. What I'd like you to do now is hit pause and try to identify each one of these things as endo or exothermic. The thing that's underlined is what I want you to look at as the system. Make sure you have that in your notes before class.